So we are discussing about different types of electrical heating. Okay, so some numerical problem I have suggested to solve it to your hostel or home. Okay, I hope you are doing it. So keep it with you as just like an assignment. Okay, when I'm asking for the assignment, you people please give it to me, submit it to me. Okay, now we're discussing the cause of failure of the heating element. So what are the most problematic issues due to failure of the heating elements? Okay, so first important thing is that that uneven heating, okay, throughout the surface. Suppose if you consider, if you are using different types of insulator, so you can see the heat gradient. Okay, so distributions of the heat, okay, throughout the surface, how it will be look like. Okay, that is very important. Okay, so how is it look like? So it can be observed that it can be observed that if you change it, okay, if you are changing, there is an uneven changing of that heating spot, then that may cause for damaging of that insulator. Same thing also happened here. Basically high voltage is appearing across the insulator, then anyhow if it is anyhow it is not evenly distributed, so that may cause for damaging of that one. Okay, same thing also happened here. Okay, formation of the hotspot. Okay, so hotspot means what happened? So if it's an uneven distribution of the heat, okay, so that may cause for what? There is an infrared emissions of that heating elements. Okay, so that may cause for infrared emissions. So that may cause for problematic heating. Okay, so what happened? So it can break. Okay, so free filament may be break. Okay, so in case of coils, you can see that heater having some electrical coils, that means resistance. Okay, so that current is flowing through the resistance. So I square at T law, I square at T heat energy means joule has been developed. So that may damage that may cause for electrical heating. So if there is uneven distributions of that electrical heat energy, so that may damage the filament. Okay, the filament may break where it shines at the brightest during its operation. That means the temperature at the particular spot. Okay, temperature at the particular spot is higher compared to rest of the filament. Okay, that is called the informations of the hotspot. Okay, so that infrared, that may cause for infrared generations of infrared. Okay, so that may cause for hotspot. It may be created due to following causes. What are the causes? Unequal spacing. Okay, unequal spacing, supporting structures. Okay, so if the spacing is unequal, okay, definitely heat gradient, heat density will be different in different places. So uneven distributions of the heat may damaging of that materials. Okay, if spacing between the heating element is non-uniform, okay, is non-uniform, then the temperature will maximum where spacing is minimum. Thus, the hot spot may be forms. Okay, so that's main cause for the hotspot. Supporting structure, if supporting structure is bad conductor, okay, bad conductor of heat, then it will transfer any heat, hence the temperature of the heating element will be higher, near the supporting results informations of the hotspot. Okay, so that are the basic issues for heating. Okay, the outer surface, the oxidations are there, oxidations. Okay, the outer space, okay, outer surface of the heating element which is open. Okay, outer surface of the heating element which is open to atmosphere get oxidized due to the higher temperature. Okay, during switching operations of the oxidized layer gets flicked off, and due to the inner surface is now open to the atmosphere. Okay, that may cause for the oxidations. Okay, so oxidations happen. Okay, So if that is the temperature, okay, that temperature is responsible for chemical changes of that material with the presence of the air. Okay, so that may cause for oxidizations. Okay, so am, ambient due to the gain growth. Okay, what are the gain growth? The all heating alloy containing iron train. Okay, iron train to form large brittle grains at higher temperature, at high temperatures. Okay. When cold, okay, that may cause for it. When cold, the heating element are very brittle and liable to the rupture easily of the slightest handling and the jerks. Okay, and that all the cause for heat cold that try to be different behavior. If hot condition, different behavior, so that may damage. Okay, the heating materials. Then another important issue is that corrosions. Okay, chemical farms. Okay, producing during the industrial operation corrode and the surface of the heating element where the actual contact of fumes with the heating element occurs due to the failure of the heating elements occurs. So corrosions is another issues. Okay. Next one is the mechanical failure. Okay, so mechanical failure means during the alloying. Okay, during the alloying, when you are preparing the alloy, means mixing up that different materials. Okay, up, up, portions of the heating element may have a higher content of higher resistivity metals or materials. Okay, so these portion will produce more amount of heat for the same current level. Okay, thus the heating element may be damaged. Okay, that may cause for damage of the heating element. Okay. Now temperature control of the resistive furnace and oven. So that's a very important why temperature control are there. So automatically you can vary the temperature. That will be the benefits for temperature control. Okay. So the temperature control, why it is necessary, means you know that when it will be reached the above threshold, automatically the oven should be off. Okay, if it is reaching to the lower threshold, automatically the oven should be on. The temperature control is necessary in resistance oven or furnaces. Temperature may have to be kept constant or the varied according to the requirements. Okay, control may be manual or automatic. So both the way it can be possible. In this heating, okay, heat developed depends upon the I square T or V square T by R. So that there are three ways in which the temperature can be controlled. Okay. So automatically how the temperature will be controlled. So first one is that you can see I square T. Okay, so in form of I, R and T, time, okay, and current. So you can replace that I equal to V by R. So I square means V square by R square into R into T. So R are cancelled, so V square T whole divided by R. Okay, three ways are there. By varying the applied voltage. Okay, by varying the applied voltage, so the elements or the current flowing through the elements. Okay, so you are changing that heating by using the varying the applied voltage. Okay, voltage across the oven. Okay, voltage across the oven can be controlled by changing the transformer tappings. Okay, so as simple as it, you can change the transformer tapping. So automatically it can be varied. Okay. This is economical and most suitable if the transformer, okay, if the transformer is to be used for stepping down the voltage for the supply to oven or the furnaces. Okay, but such conditions do not arise usually. Okay, so it's simple. You can change the tapping, that voltage level can be changed, and automatically you can get it. Okay, the value. Autotransformer or induction regulator. Okay, so instead of transformer tap changing, you can also use the autotransformer or induction regulator. Okay, for the variable voltage supply. Okay, different voltage level you can change it. Okay, alternative voltage across the oven or furnace can be controlled by varying the impedance connected in series with the circuit. Okay. So that can also be possible. Okay, so alternative voltage across the oven furnace that can be possible. Okay, impedance control in the series with the circuit. By this method is not economical as power is continuously wasted in the controlling resistance, therefore limited to small furnaces. Okay, we can limit it to the small furnaces. Next one is what? That was controlling of the voltage, first one. Second one, varying the resistance of the elements. Means, you know, you are using charge. Okay. So temperature can be controlled. The temperature can be controlled by switching the various combinations. Okay, various combination of group of resistors used in the oven or the furnaces are the following ways. Okay, what are the options? Okay, that we can that we can change over here. So first one is the variable number of elements. Okay, we can change the number of elements. In this method, the number of heating element in working is changed, so total power input or heat developed can be changed. Okay, so number of heating element has been changed, so automatically all those things has been changed. Okay, this method does not provide uniform heating unless the number of heating elements, okay, in the circuit particular instant distribution over the surface area. Okay, so how it will be provided throughout the surface? Okay, that if it is has been changed, okay, and automatically the entire process will be varied. Okay, change in the connections, change of connections. Okay, so the element are arranged so the connected either in all will be in series for high voltage applications or in the combinations of parallel for high current applications, or it may be for, if it is in three phase, so it can be combined as like a star connected conditions or delta connected conditions. Sometimes zigzag conditions can also be possible. Okay, so how you are rearranging your elements, okay, and optimizing the total surface, optimizing the total effective resistance. Okay, by that way you can combine them and we can arranging them. Okay, so by varying the ratio of on or off times of the supply. Okay, and on off switching. Okay, and on off switch can also be employed for temperature control, but its use is restricted for the small ovens. Okay, to small ovens it can be restricted. The time duration for which the oven is connected to the supply and the time durations for which it remains cut off the supply will determine the temperatures. Okay, when so now it depends upon the time, integrating factor of the time. So on off means you are varying the duty ratio. So T on by enter time. Okay, so how many percentage it is duration it is turned on. Okay, that you can control. Yes, so it's not so much complicated, it's very simple. Okay, so here you are able to varying that on time and off time, means cut off time you can also vary. Okay, so oven supplied through the thermostat. Okay, thermostat switch which makes and breaks the supply connections at the particular temperature. Okay, so for which temperature it is applicable that we can understand. The ratio of time duration during which supply remains on to total time duration of an on-off cycle in the induction temperature. That also been possible. Okay, induction temperature that also possible. How many times it's turn on and turn off conditions. The higher the ratio, the longer with the temperature of the oven. Okay, advantages of the method is that the more efficient than the series impedance method. Okay, so these all are the basic conditions how we are varying the temperature in the controlled manner. Okay, so now most important, the design of resistance setting element. Okay, so here what are the factors are related to this one? That is very important. And in case of mathematical implementations, okay, that we can also use. Okay, that very simple formulas are there. When we are going for the mathematical implementation, we are using those formulas to directly get that values. Okay, the purpose of design heating element, okay, is to find the size length of the wire required as the heating element to produce the given temperature can be calculated when we know the electrical input or the voltage. Okay, so if the electrical voltage and currents are available, so we can directly get it from the formula. Okay, so that we are using designing the elements, so it in which application we are implementing, that is also important. We are implementing for the filament behaves like a filament, so then it will be look like a the cross section will be cross section of the material will just like a circle. Okay, sometimes we can also use the material in combined material, different materials we are preparing at a say for the combinations. Okay, all the thin wires we are combiningly were combined such a manner so it behaves like a thick wire, and sometimes maybe look like a rectangular inside. Okay, it depends based on the applications. Sometimes look like a ribbon. Okay, the heating element or the reaching of the steady state temperature will dissipate the heat from its surface, the equivalent to electrical inputs. Okay, generally the heat will be dissipated from the heating elements at high temperatures. It is reasonable to assume that whole of the heat energy is dissipated by the radiations. Okay, the heat dissipated according to the Stephen's law. Okay, that laws are there. H equals to a 5.27 or 5.72 ke T1 by 100 whole to the power 4 minus T2 by 100 whole to the power 4, that is watt per meter square. Okay, so where T1 equal to temperature of surface of heat in degree centigrade, T2 is the temperature surface to be heated in degree centigrade. K is the constant known as the radiant efficiency, is the emissivity. So all are the important factor to calculate that value. Okay. So electrical inputs, what are the electrical inputs? P equal to V square by R. P equal to V square by R, where V equal to supply voltage, R equal to resistance of heating element. Two important factors are there. Okay, now you can see for that circular wire, if the wire is in circular in nature, you know that R equal to rho L by A. A is that area. Okay, cross section area of the material. Okay, so based on the nature of the material, that A has been changed. Okay, for circular area, that is pi r square. Okay, that is pi r square. So R is d by 2, so pi d by 2 whole square, rho L by. So rho L by pi d square by 4. So R equal to 4 pi L. Okay, 4 rho L whole divided by pi d square. So d is the diameter of conductor, L is length of the conductor, rho is the resistivity of the conductor material. P equals to what? V square by R equal to V square pi d square whole divided by 4 rho L. Okay, so now L by rho, sorry, L by d square. Okay, L by d square is how much? It is coming. L by d square means how much it is coming. Okay, cross multiplications. Okay, L by d square, it is coming V square rho, sorry, V square pi. Okay, into 4 rho into R by this. So it's not required. So P in form of P directly we are getting L by d square equal to rho pi v square by 4 rho into P directly. So now surface area you can write that S equals to pi dl. Okay, total heat dissipated HT equal to pi dl into H, where H equal to heat dissipated per unit area. Okay, at steady state temperature, power input equal to heat dissipated. Similar, P equal to rho dLH. Okay, so it is rho d square v square by 4 rho L equal to pi into d L H. Okay, so d by L square equal to 4 rho h whole divided by V square. So rectangular or the ribbon wire, okay, how it will be look like that, the area will be changed, okay. If it is W, thickness is T, length is L, so directly it will come in rho R equal to rho L by A. So rho L by W into T. Width of the conductor, L, length of the conductor, L, T is the thickness of the conductor. So W into T, it's a rectangular in shape, so W into T. Okay, so putting in equation 2 that form on, so V equal to V square by R into V W T whole divided by rho L. Okay, so L by W T equal to V square rho. That it is coming. Now, what is your total surface area? S equal to 2 into WL. Two surfaces are there, W into L. So total, you can find out the volume. Okay, total surface. Okay, total surface 1, 2, 3, 4, 5, 6 surfaces are there. Okay, so 2 into W into L plus 2 into T into L plus T into W. Okay, so neglecting the side area, 2T into L plus T into W, okay, as the thickness are negligible. So it's a conductor, so this portion, that hashed portion, you can see they are not considering. Okay, they're neglecting. So that the heat is dissipated equal to 2 into WL into H directly. Okay, where the H equal to heat dissipated by unit area. The steady state temperature equals to power input equal to heat dissipated. So P equal to 2 WL into H. Okay. So now you are directly get that son V square WT whole divided by rho L equal to 2 WL into H. So you can also find out the final. These all are the equation. Now solving equation C and D. That equation C, this one is your C and D. Okay. The length, width and thickness of the wire can be determined. Okay. Electric immersion heater. Okay, that fundamental things are there. What are the fundamental things of electric immersion heater? So at the time of exam, this simple thing, simple question may become, okay, write down the mathematical, write down the brief discussions on electric immersion heater. Okay, how it is working, what are the few important factors of that immersion heaters. Okay, so it works on the particular principle of the electric heating effect. Okay, of an electric currents. Okay, here you can see terminal housing is there. Okay, the rest of the covering. Then it is a power P equal to 30 volt AC, N P into N. Okay, and the terminal housing, then indicators are required and heating elements. Okay, that means immersion heater means which immerses the water. Okay, this is electric immersion heater. Important points. What are the most important points for immersion heater? First is metallic tube. Okay, metallic tube is required where that copper chromium plated. Okay, it is made of that copper chromium plated. Okay, and that hollow tube at that protected is the inner part and absorb the heat from the inner part of the transmit the heat to the liquid or the water to be heated. So you are immersing that thing inside of the water. So it is heated. Heating elements. Okay, the heating element is made up. Okay, the heating element is made up of that high melting. Okay, made up of high melting nichrome. Okay, having more resistivity. Okay, having more resistivity. It is in the form of the coil and placed inside the copper tube centrally. Okay, so heating element means that you are making that coils that will be inside of that hollow tube. Okay, you are placed over there and you are just giving a potential across that hollow that coils and you are making them heat. Okay, the coil is connected. Okay, the coil is connected to the electric supply through the terminal housing. Okay, terminal housing and the supply cord. Okay, the coil is heated up and the produces the necessary heat. Okay, coil will be heating up and produces the necessary heat. Okay, insulating powder, the gap between the heating element and the tube is filled with the insulating material like MgO. Okay, that material is having good insulating property at high temperature and at the same time it is a good thermal conducting materials. Okay. The other part, such as the terminal housing supply cord, okay, minimum water level indicator strip, these all are the important factors or features. Okay, it is used, it is used, okay, in 0.5, 1, 3, 5 kilowatt for the heating water or the liquid. So different. You know that operations of the geyser. So similar kind of things, similar kind of options are there. Okay, if the two terminals are touching together, the short circuited options, short circuited may cause, and that can be fault. This is checked by the test lamp. Okay, if there is a break in the heating element, this fault is a open circuited fault. Okay, it is checked by the connecting the test lamp in the series. If the lamp does not glow, it indicates the open circuited fault. One end of the test lamp is connected to one terminal of the heater, another is the connected in the heated body. The lamp glows, there is a earth. Okay, so these all are the very functions, features of that electric heater. Here you can see that we are just talking about electric geyser, how it will be look like that. So hot water, you know, that is a just reversing. Okay, so geyser is connecting, you know, that hot water out and cold water in. Okay, now if any possibilities, so there is an option of the overflow. Okay, so now heater one is there. Okay, it is your anode. Okay, and it is your water tank. Now heater 2 is there. Okay, it is your thermostat. Okay, thermostat is there, heater 1, heater 2. Okay, so outer casting is there. Outer casting, this is your insulating material, and the drains are there. Okay, now how it will operate? Simple, electric heater, water heater. So water is taking inside that cold water, definitely it's your hot water. Automatically water will be lesser density, so automatically it will be the floated over there. Okay, hot water positions, and cold water are bottom positions. Okay, now what happened? The heater 2 will be turned on and heater 1 both are there, both way it will be thermostat. Okay, so automatically turn on, turned off condition, thermostat. So temperature sensing conditions are there, means bimetallic strip. So when the temperature will be more, okay, automatically it will be off. When the temperature will be less, automatically it will be turned on. Okay, so that provisions are there, and based on the turn on turn off condition, heater will be turned on. So first this it is cooled water, so heater 2 is turning on, heater 1. So if it is more, then you know that geyser. So if the entire portion will be filled by hot water, so in that case no need to turn on the heater 1 and heater 2. Till now if you evacuate that hot water, okay, then automatically off. So you can see the drum. Okay, so drum having some coating. Okay, two coatings are there. Okay, otherwise what happens? The heat will be dissipated inside of the drum to outer nature. So automatically it will be dissipated, but it having some time. Okay, so automatically suppose if your geyser switch is turned on, then automatically when the temperature will be below of the threshold value, automatically the heater switch will be turned on. If it is more than that switch, so it is turned off. And sometimes what happens, indicator, one outer side indicator is there that can also indicate the tank temperature. So storage tank temperature. So that also be used for the protection purpose. You can also understand if the storage tank temperature is going high or down. Okay. So the special type of water heater working in the simple principle of the heating effect. Okay. So important factors, what are the important factors? Water storage tank that we are talking about, water storage tank, heating element, okay. Then anodes are there, thermistor, earthing arrangement, okay. These all are the most important factors. Okay, so water storage tank. So two cylinder, one of which called the heating chamber, another made of that thin copper, and other part is the lead casted steel. Okay, remaining the space between two is filled up the glass wool insulating material. So otherwise heat will be dissipated. So preventing of that heat. Heating element, the heating element made up with the nitrum one. Okay, nitrum wire may be one or two in that fitted with the chamber. Nitrum wires are there, so that will be inside of the chamber. Water inlet and outlet arrangement must be there. Anode rod come insulated with geysers and are generally made of the magnesium or the aluminum, which are screwed into inside of the geyser. Okay, this anode prevents the corrosions of the geyser by the self sacrificing. Okay, its material having attract the corrosions of the water, minerals, element, rust. That's why the anode wire is there. Okay, so if any, there is a lot of materials are there, minerals. Okay, some of the corrosive in nature means that may responsible for that gives a chamber degradations or any other metal degradation. So if that cannot metals are there, that will be self sacrificing metal, means automatically they are combining with the chemically combining with that material. So okay, and it can be sedimented just below of the tank. Okay, thermostat, so automatic switch off arrangement after reaching the required temperature of the water. Earthing arrangement, the body of the tank is well earthed to avoid the electric shock. That I am talking about, the protection is there. Operations in the similar of the immersion heater, more or less similar of the immersion heater. Okay, so today I have completed up to this portion. Okay, the immersion heater, geyser, and some mathematical steps. Okay, so any doubt if you have, please let me know so I can rediscuss some of that portions. I hope you are able to understand. Nothing complicated portions, is very simple thing. Any doubts from your end? Is there any doubt from your end?
No, sir.
Okay, so then you don't have any doubt, no problem. So here I am just concluding the session.